May I have your attention, please? Kormarine Conference 2022 will begin shortly at 10 o'clock. Please come in and take your seat. As courtesy to other participants, please turn off your mobile phone or put it into silent mode. A simultaneous interpretation service is available for this conference. Please listen to Channel 1 for Korea and Channel 2 for English. 네, 다시 한번 컨퍼런스 장내 안내해 드리도록 하겠습니다. 잠시 후
May I
10시부터
have your
코마린
attention, please?
컨퍼런스가
From 10
시작되게
a.m., we will begin Kormarine Conference
외부에
2022.
계신 분들은 착석하여 주시고
All the
함께
participants
10시부터
are
컨퍼런스를
kindly
준비할 수
requested
있도록
to
자리에
be
와주셨으면
seated.
감사하겠습니다. 또한 코마린 컨퍼런스에서는 동시 통역기가 준비되어 있습니다.
Kormarine
통역이
Conference
필요하신 분들은 메인에 있는 운영 사무국에 요청을 하시면
provides you with simultaneous
자세하게 안내해 드릴
translation.
예정입니다.
If you need a receiver, please ask the staff at the lobby.
This is the last announcement for Kormarine Conference. May I have your attention, please? Kormarine Conference 2022 will begin shortly at 10 o'clock. Please come in and take your seat. As courtesy to other participants, please turn off your mobile phone or put it into silent mode. A simultaneous interpretation service is available for this conference. Please listen to Channel 1 for Korea and Channel 2 for English.
be something I said, could be something I did this time. Maybe it's even scared. You just blew out my mind. We were covering the light.
안녕하세요. 반갑습니다. 오늘 코마린 컨퍼런스 인천에서 시작해서 어제는 우리 해양 미래 인재들의 그림 공모전 시상 그리고
Actually,
제1회 해양 토론 대회까지
in the Kormarine Conference 2022, we had the National High School Students Debate Competition and Children's Painting Contest and Photography Contest as well. And we had wonderful sessions yesterday. And today we prepared excellent sessions for all of you. Then we're going to start the second day of Kormarine Conference 2022.
Welcome to the second day of Kormarine Conference 2022. This is Ajin Kim, professor at Dongsu University, and it's a sincere gratitude to be MC again on second day. We have 3 sessions for today. Session 3, development and industrialization of autonomous vessels. Session 4, future ships and then digital ports. Session 5, seminar on overseas market entry. Let's start session 3. The first speaker is Do-hyung Im, CEO from Abacus. His presentation title is Mass Technology Development and Commercialization Status of Hyundai Abacus. Please give him welcome and big round of applause.
예, 반갑습니다.
Nice to meet you all. I am the CEO of Abacus. My name is Im Do-hyung. Last year, our company was founded, and we are actually a spin-off company from Hyundai Heavy Industry. We have about 50 employees, and these employees are from Hyundai Heavy Industry, researching the autonomous navigation functions. Today, I would like to share with you our autonomous navigation solution. First of all, I will introduce to you our company and our solutions and projects, and then explain about the technology specification or demonstration of our solutions. First, about our company. In terms of economic benefits and safety, it is inevitable to move towards autonomous vessels. So from 2014, we started smart ship solution research activities from Hyundai Heavy Industry. And from 2009, we developed navigation assistance system. And in this system, we commercialized low degree of autonomy. And last year, our company was founded, and we aim to develop autonomous navigation system in 2024. As explained before, we were spinned off from Hyundai Heavy Industry. We are specialized in developing autonomous navigation solution for vessels. Our mission is to achieve accident-free navigation through revolutionary marine mobility with autonomous technology. Our solutions. As other robotic solutions would be, we have 4 key technologies, including detection, situation analysis, planning, and control. Especially, we have vision sensing technologies, surround view system, collision warning system, collision avoidance, and auto docking technologies. We have 2 solutions. One is for ships, which is called Highness. The other is the solution for small and mid-sized ships like boats. The name is AI Boat. We use the same technology for these 2 solutions. Before talking more about our solution, I would like to explain the degree of autonomy. You may be very much familiar with the IMO's degree of autonomy. And I would like to compare IMO degree of autonomy with a more detailed classification of autonomy level defined by 1 CEA, SEA. Starting from level 1 to level 5, level 1 and 2 refer to assistance system, and from level 3 to level 5, this is autonomous system. Up to level 2, the mariner takes responsibility for operation of the vessels, and from level 3 to 5, the system takes responsibility. It has been 20 years since ADAS was adopted in the automobile industry. In most of the new car models produced by Hyundai, ADAS is included. The same will happen in the shipping industry. We name this HINAS, the navigation assistance system for vessels. We will upgrade the technology based on the track records, and our aim is to move up to the level of degree 3 autonomy. Our solution consists of HINAS and HIBAS. HINAS consists of vision sensing, which detects objects, and it also consists of sensor fusion and AR visualization that prevents collision and helps safer navigation. HIBAS is consisting of a round view image, top view, and it uses LiDAR to show the distance estimation, and it shows 3D blind spots. And HINAS 2.0 is a solution that has control functions as well. So it helps with autonomous navigation with collision avoidance. On the top right, you see the camera, the HINAS camera. It shows the 180 view surrounding the vessels. An IR camera covers 150-degree view. This is our core vision sensing technology. We use cameras to recognize objects through deep learning algorithm, and we can also classify objects. We use IR camera so that during night or when there is heavy fog, we can automatically detect any objects or obstacles during navigation. And the existing sensors have their own advantages, so we conducted sensor fusion. Through this technology, we can warn collision risks, and we can also help safer navigation to avoid no-go area, for example. This is visualized on the display, so a monitor that looks like this is installed on the system on board the ship. Next is HIBAS. HIBAS provides 360-degree top view AR image. It uses 32-channel LiDAR. And if the ship comes closer to any object or obstacle or other ships, then it gives an alarm showing the distance between the own ship and the other objects. And it shows the 360-degree top view so that the ship could see or the mariners could see any blind spot surrounding the vessels. This is the situation awareness function. Hyundai Group developed route optimization program. In connection with the route optimization program, we enable the vessels to automatically avoid any collision. We cooperated with the Hyundai Heavy Industry and other materials providers so we developed the autopilot BMS, and we also completed the interface between them. Next one is the solution for small boats. In this solution, route planning, autonomous navigation, vision sensing, collision avoidance, and warning, as well as control functions are included. It provides 2D surround view, 3D around view, and it also provides auto docking function. This solution is also available on the mobile phone. We developed this solution for small and medium-sized ships. So all the solutions I explained to you up to now are at the level of ADAS level 2. So these are assistance system or assistance solutions for drivers or for the people on the vessels. Our aim is to upgrade the autonomy level of our solutions. So last year in Pohang Canal, which is about 10 kilometers long, we conducted a test. We showed the autonomous navigation performance of this vessel in cooperation with KAIST. We used LiDAR and computer vision. Also, we received help from KT. So the headquarter office of KT helped us remotely monitoring this test process. And this was often reported through the press and media. We conducted transoceanic voyage from the US through the Panama Canal to Boryong of Korea. We performed the transoceanic voyage. We sailed through the area where there's not much traffic. So a fully autonomous navigation was tested and completed without any human intervention. We encountered about 100 ships during the navigation, and Highness kept the courses 70 times and avoided the collision 30 times as it recognized the object and ships. And we conducted route optimization and speed optimization during navigation. And we found that the fuel efficiency was improved by 7%. We developed Highness 2.0 through long years of efforts. This is a system that helps with collision avoidance. We have continued the development of this solution for a long time, and we have updated this function. And our Highness and HICAS collision avoidance logics were combined with each other, and this was interfaced with the other solutions, and we conducted many field tests, real tests, many times. And at the test commissioning phase, we conducted simple interface test. And this June, we tested this solution by having transoceanic voyage. And ABS issued SOF, Statement of Facts, for the solution, recognizing the value of this solution as autonomous navigation solution. And we received AIP from ABS, and we plan to receive certification from the class by next year. And we are also preparing for type approval. Also, we need the approval from flag states to actually enable operation of this vessel, so we are cooperating with flag states as well. Lastly, Hyundai Heavy Industry recognized the value of Highness 2.0, and although this is not strongly fully confirmed, there's a plan that Highness 2.0 will be installed in all the newly built vessels from 2023. So the ships built from Hyundai Heavy Industry will have Highness 2.0 by default. Next is our commercialization status. We started Highness and Haibus projects from last year. We already received orders for 230 ships, and we installed this solution for 10 ships as of now. And Highness 2.0 has control functions. We received orders for 23 ships, and we are going through the class certification process, and we have discussed the basic design and specification about this solution. We plan to develop our technologies to go beyond degree 1 and 2, but to achieve degree 3 and higher degrees of autonomy. I think that ADAS, which is Navigation Assistance System, has a high value for enabling safer navigation because more than 80% of maritime accidents were caused by human error. And once this assistance system is on board the ship, it will be helpful. Without such a system, seafarers must stay awake 24/7 on the vessels to watch for any risks, and this is in reality impossible. I believe that this autonomous navigation assistance system will be helpful for reducing human error. And if a ship has this kind of system, it will be able to receive insurance premium discount. And many young generation are not willing to work as seafarer, and we are lack of experienced seafarers. So if we integrate the experienced captain's know-how into this system, then it will be very helpful for unexperienced seafarers to conduct safer and efficient navigation. And we think that autonomous assistance system will truly help increase fuel efficiency and reduce greenhouse gas emissions. Through cooperation with shipping companies, we will gather more statistic data. I strongly believe that the system will be helpful for increasing fuel efficiency. When I go to my hometown by driving, I have to fill up my car with more diesel, the fuel. So if I drive the car, I have to buy more fuel. But when my wife drives the car, the same distance, we don't need to buy additional fuel. This is an example that if we have this autonomous assistance system, we'll be able to increase fuel efficiency. We are commercializing degree 1 and 2 solutions, and we are discussing this matter with flag states and regulatory authorities. I don't see a big issue in terms of laws and legal framework for degree 1 and 2. And it has been 20 years since ADAS was developed, and for about 10 years, there were issues of safety and reliability related to ADAS. And by 2010, ISO standards about functional safety of ADAS system was created. And the stability of a system that enables autonomous navigation and control functions could be widely used once we have clear legal standards and regulations regarding the safety and reliability of the system. As for degree 3 and 4, we will use our know-how and data from our experience with the degree 1 and 2 solutions.
그리고 말씀드린 내용인데요. 저희가 이제
And
자동차에서 봤듯이 어느 날 갑자기
as we experienced from automobile industry, it wasn't that
국내에서 다 이제 컨센서스가 있는 걸로
the
알고 있습니다.
unmanned cars or unmanned vessels will appear overnight.
될 거고
We will gradually commercialize the autonomy functions, starting from the low degrees of autonomy.
인더스트리에서 고민했던
And in the process of commercializing autonomous navigation solutions, we could refer to the experience of automobile industry, and I think that the relevant standards and regulations should be promptly established, and it all requires cooperation among relevant parties. We have a reference with autonomous cars. We could refer to the experience we had with autonomous cars in terms of preparing regulations for functional safety of the autonomous navigation solutions. Thank you very much for your
Thank you
attention.
very much, Do Hyung-im, CEO from Avicus, for your presentation. Next, I would like to introduce Oscar Rivenders, SVP from Congress Maritime. His presentation title is Development Trend for Remote and Autonomous Vessels. His presentation is pre-recorded and he will join us in real time for the Q&A session that will take place later. The presentation title is Development Trends for Remote and Autonomous Vessels. Please give him a big round of applause.
Ladies and gentlemen, my name is Oscar Levander and I work for Kongsberg Maritime. First, I would like to thank the organizers of Kormarine Conference for inviting me to speak here today. Unfortunately, I cannot be there in person, so I'm sending this video recording of my presentation instead. The topic of today is recent development of autonomous vessels that we are working on in Kongsberg. But to set the scene a little bit, you can say that there are two main trends in the maritime industry. One is around the environment, and the other one is around digitalization. And on the environmental side, one of the main sub-trends that we see today is the energy transition or fuel transition, whatever you want to call it. And that is when we're going to shift towards low carbon fuels. On the digitalization side, on the other hand, the main sub-trend is probably remote autonomous shipping. And that is the topic of my presentation here. You can say that digitalization is going to change our industry. Yes, it's going to bring a lot of new technology, but it's not only about adding fancy gear and new tech on board. It's actually about how this digitalization will change the operation, the way we manage our vessels, and the way we do business. On the operational side, we're going to see the introduction of remote control. We're going to see how vessels are going more autonomous, and this will enable the people to do more value-adding tasks than to just navigate and do lookout. So we can expect much more performance out of the vessels in the future. It's also going to change the way we manage our ships. It's going to bring in tools like predictive maintenance and ways of kind of optimizing the service we do on vessels. It's going to enable remote connections, so you don't always need to travel on board a vessel. You can have an expert in the loop that is supporting things. And fundamentally, it's going to bring totally new business models to our industry. And one of these big changes that we're going to see driven by digitalization is the introduction of remote autonomous ships. When we talk about this, many people quickly think about unmanned shipping. And yes, we will have unmanned ships on the water in the future. But remote autonomous is a much broader topic than that. There are many aspects related to it. The technology that we are developing for autonomous shipping will also go on board manned vessels. So we're going to see more advanced maneuvering systems. We're going to see enhanced navigation tools, and we're going to basically improve the safety by bringing on board situational awareness. And we're also going to connect up the vessels with the shore operations. So we're going to have remote operation centers from where a lot of different tasks are performed, both for manned vessels, but also unmanned vessels. So there's many different aspects of remote autonomous. If you look at the timeline, you can say that we are still in the early days of the development of remote autonomous vessels. We are still learning. Yes, we have some smaller USVs on the water that are in operation, and we are working on some short sea vessels to gearing them up. But it's still early days. Eventually, we're going to move on to more vessels, slightly larger vessels, and then at the end, we're going to move towards large ocean-going cargo vessels that operate internationally. The timeline of this is still a little bit open, and probably what is going to set the time of the introduction of international shipping is more the regulation rather than the technology. And hopefully, we will have IMO regulations in place in about 10 years' time from now. At the same time we see these ship applications, we will see also a lot of other tools and equipment that will be rolled out as standalone products from this remote autonomous development. For example, we already have automatic crossing and docking functions, and situation awareness is coming very soon. So there's a lot of standalone products that we will roll out over the years here as well. So for example, one of these products that is coming or is already here is situation awareness. That is really when we take a lot of sensor input from radar, camera, AIS, digital charts, and so on, and fuse all that together to create a holistic view of what's happening around the vessel, to create a better awareness for the crew on board the vessel. And of course, this will also be used for the autonomous system when it's navigating to know what's happening around the vessel. And I think in the same way that we today have radar on board vessels and take it for granted, and it's actually mandatory to have a radar on ships. In the future, basically all ships will have situation awareness, and it will become mandatory to have on board bigger vessels. So it is one of these great technologies that will enhance safety of shipping. Another thing that we also have in place is advanced maneuvering functions, such as automatic crossing or automatic docking. Here in the video, you see Buster Fosen's ferry that automatically can transit from one port to the other one. And the point with this is to basically do the crossing more efficiently and consistently. You can see on the left-hand side of the chart the difference between manual operation and automatic operation. But in this case, I mean, this is still automatic. It's not autonomous. So the captain is still on the bridge and he needs to watch out for other traffic and avoid other ships. And that is the next step of the development, to turn this into an autonomous navigation system. And we are working on this. And when we're talking about autonomous navigation system, it's everything from basically planning the route that the vessel should take into executing that. And then, of course, when you execute the route, the system should also avoid obstacles and avoid collisions. And it needs to do this in a call-right compliant way. When we think about unmanned ships, we always refer to this as remote and autonomous, because it's always going to be a combination of remote operation and autonomous operation. A pure autonomous or pure remote ship is probably quite unlikely, because you always need to have a remote supervision, even for the most advanced autonomous vessel. You want to be able to see what it's doing and step in if something happens. And in the same way, for a remote controlled vessel, if you lose connection, the ship needs to have some autonomous capability to know what to do in that situation. So we always see it as a mix. And for having remote operation, you need a center from where to drive the ship and supervise it. And we have built these operation centers for that. And there's a lot of different functions that you can do in an operation center. For existing vessels with crew on board, you can do remote monitoring and you can support them, having a kind of expert in the loop. And then when it comes to unmanned vessels, you can actually control them, remotely steer them, or you can monitor or supervise what they are doing. And we can also think about actually controlling ships with crew on board. We can, for example, let the crew rest at night while the basically team in the remote operation center take over. So you can more efficiently plan your what the crew is doing and what they are doing and maximizing their performance. And it's not only about individual vessels, it's also about the entire fleet. So the remote operation will also do mission management, scheduling things, resource management, planning, maintenance tasks, and a lot of other things that will be done in the remote operation center. So you see, there's a lot of different type of operations that will be done from these remote operation centers in the future. And we have done many prototypes of this center. And this is the first station that we have delivered for a commercial client. And this is for Masterly. And this will be used for operating some of the vessels that I will talk about later here in my presentation. But first, Masterly is an interesting company. It's a joint venture between Kongsberg and Wilhelmsen. And it's really there to develop autonomous maritime market. You can say that Kongsberg is bringing the technology part and Wilhelmsen is bringing the operation experience. So Wilhelmsen has got a vast experience of operating hundreds of ships out there and is one of the companies with the largest maritime network out there today. So it's great to team up with them and form this Masterly that will service the autonomous shipping market. Then to look a little bit about on the different projects that we are working on right now. We have many different projects related to remote autonomous ships, and many of them are in the development stage, but also some are already on commercially ready, like this sounder. So this is a small USV that we call the sounder, and this is really for performing hydroacoustic tasks. So it's an unmanned vessel that can go out and survey the seabed, or it can go out and find fish. And that is actually the first application for this vessel. It is used to monitor and search for fish so that the larger fishing vessels don't need to spend time and energy on going around to try to find the fish. So basically this sounder will report back to the fishing fleet where the fish is, and the fishing fleet can directly go and start fishing. So this is about saving cost and energy and utilizing your resources more efficiently. Then maybe a more known project that hopefully many of you have heard of, and that is Yara Birkeland. This is a zero-emission container vessel that will become remote, autonomous, and unmanned. The ship in itself is designed to transport containers from Yara's factory to a bigger seaport where bigger ocean-going vessels can access and then transport the containers further out into the world. And today, the operation has been done with trucks. So this is really to take trucks off the road and do it more environmentally friendly, because this ship is powered by batteries. It's 100% electrical, this ship. It's also going to be automatic in mooring on board and cargo handling. And it's going to be operated from Masterly's station in that I showed earlier. And Kongsberg is bringing the remote autonomous system and the integration. And right now we're also doing the wheelhouse of the vessel that will eventually will come off. The project itself started back in 2018 with the planning and then the designing of the vessel the year after. And in 2020, the construction of the vessel started, and in 21 it was delivered. So basically the vessel is there, but it's currently a manned vessel. And we have this small bridge on the ship that will be lifted off. And right now we are basically doing testing and development of the remote autonomous system and ensuring that everything is functioning. So if you look at the timeline, we are now really, we are operating the vessel, but also at the same time testing and developing the remote autonomous solution. And when we are happy with the performance, we will go for approval, and then hopefully in 2024, the vessel will start its commercial operation in unmanned mode. And then there will be no deck house on the vessel anymore. Another project that is ongoing at the same time is for ASKO. ASKO is a gross retailer in Norway, and they have a lot of trucks driving around with products. And they want to cross the Oslo fjord to avoid driving around the whole fjord. And this can be done with a small ferry. And they want to do it environmentally friendly. So they have commissioned 2 battery-powered ro-ro ferries to take trucks across the fjord. And these vessels will also be unmanned. So we are in the process of developing and outfitting them for remote autonomous operation. Currently, the vessels were delivered now during the summer from Asia to Norway. And in Norway, they will then be fitted with the remote autonomous technology. And they take about 16 trucks per vessel. Another exciting project is for Reach Subsea. This is a totally new type of vessel. This is a ROV mother vessel that is unmanned. So an ROV, or this remote operated vehicle, this submarine, that is doing a lot of different tasks underwater, is normally supported by a big vessel on the surface. And that vessel is providing power and connection, and you have the operator sitting on board the vessel. What Reach Subsea want to do is to move the operator ashore to enhance the work environment, and also at the same time reduce cost and improve efficiency. And that they will do by having, instead of having this big mother vessel at the surface, having a small unmanned surface vessel that is providing power and connection to the ROV. So you see the ROV is coming out from the bottom of this mother vessel, and it gets the electrical power and connection from the vessel, but also this mother vessel will do the launch and recovery. And in fact, the mother vessel can also do some surveys of the seabed with sensors fitted to the hull. In general, the exciting thing with this concept is how it will disrupt the market. Because you can imagine that today, when you have an ROV, you normally have an offshore support vessel at the surface that is maybe 60 or 100 meters long, and it has 20 people on board. That costs a lot to build, and it costs a lot to operate. When we replace this mother vessel, this big manned vessel, with a small unmanned 24-meter long remotely operated vessel, we will save a lot of money. The investment cost will go down because this remotely operated vessel is so much smaller. The energy demand is much smaller, so less fuel consumption. And of course, the operating cost, the crewing cost will also go down because we have significantly less people involved. So the vessel itself is unmanned. There's just some operators in the shore center. So it is really going to disrupt the market of ROV operations by going this way. Other exciting projects that we are working on are, for example, for Ekornes and DB Schenker. They are looking for a similar ro-ro ferry to transport trucks as for ASKO case, but in this case, the vessel will operate in Ålesund and slightly longer distance. And this will also be a battery-powered vessel. And it's a FEED study at the moment. And then we are working on a EU project called AutoShip. And there we are working on remote autonomous systems for a fish feed carrier and an inland waterway barge. So when we look at all these projects that we have ongoing, you can see that there are clear drivers for going for remote autonomous operation. Maybe the main one is money. We can save a lot of cost, both, especially on the operating side, we can reduce the cost, but also in some cases we reduce the cost on the investment side, the capital. And that is when we can go to a smaller vessel, like for the Reach subsea case. So there is a strong monetary driver for going for remote autonomous. Another driver is the environment. As you saw, many of these vessels that we are working on are actually battery powered, and the customers want zero emission. So you can say remote autonomous go hand in hand with sustainability. And even if you don't go 100% battery, I mean, the vessels tend to be smaller, consume less energy when they are unmanned. Safety is another driver. We provide a safer working environment for the people. If they can sit ashore instead of on the ship, it will be safer. But also the technology will drive up the safety when we have automatic systems doing the watch out. It's always alert, it doesn't get tired and things like this. So we can enhance safety as well for these vessels. Other owners that are going for remote autonomous is looking for risk reduction or totally new business models, like in the case for Reach Subsea. When we look at the development of this remote autonomous shipping, you can say that you can identify two different paths. One path is where we incrementally increase the automation level in the vessel. So for example, we add situation awareness, then collision avoidance, and then maybe we go to a solution where you can have a zero manned bridge for part of the voyage, but still have crew on board the vessel. And this is the kind of, we add on more advanced automation step by step, and we prove it along the way. The other pathway is where we go to a fully unmanned remote autonomous vessel from the start, but we start with a small vessel. We start with a USV, then we go to a workboat or a ferry, and then we scale it up to a small cargo vessel going short distance, and then we go to slightly bigger vessels going longer distance until we get to the final solution of big ocean-going unmanned vessels. And in Kongsberg, we are actually working along both pathways. As you see, many of the projects we right now have in our under development are for this kind of completely remote autonomous solutions, like this Asko ferry or the Reach Subsea or Yara Birkeland. While then many of the products that we are bringing along, like auto crossing, auto docking, collision avoidance, and these things, are along the other pathway. Personally, even though we are working on both pathways, I personally think that that the blue pathway, or going for a full unmanned solution from the start, is going to bring us quicker to the end goal. And that is because there we see a stronger business case. Already from these small vessels have a very good business case behind them, and that means that there is a strong market pull from the owners for going this way. And that will probably get us to the end goal a little bit quicker. But to conclude, you can say that the remote autonomous revolution is happening. It is here. We can see it. We have so many projects and interested owners right now that we are clearly on the path to this. And when you look back, I mean, in 2013, 14, when I started developing these solutions, we had a slogan that said that the best way to predict the future is to create the future. we had the vision that, yeah, remote autonomous shipping is coming. And we really thought that the best way to ensure that this prediction will come true is that we take an active lead and we develop it and we create this future. And that is what we did or are in the middle of doing. And you can say that it's been quite a successful journey so far. And we are truly on the verge of a new era in shipping as we know it. Thank you very much for your attention.
Thank you very much to Mr. Oskar Wibander, Senior Vice President from the Congress Maritime. For the next presentation, third speaker is Dongjin Yo, Senior Director from CRISO. His presentation title is Development of Advanced and Intelligent Navigation System and its Performance Verification. Please give him a big round of applause.
Good morning, ladies and gentlemen. I am Yo Dongjin from CRISO. First of all, I would like to thank you for giving me this opportunity to make a presentation in this important conference. I am going to talk about the development of advanced intelligent navigation system and its performance verification. Autonomous vessel has been the buzzword around the world and many technologies have been developed. And navigation system is especially getting great attention from the industry. And we need to develop the technology at a more evolved and higher level. Today, my presentation begins from Korea Autonomous Submarine Vessel project, and I will talk about development of advanced intelligent navigation system. And thirdly, I will talk about how we can establish the test environment for the system. And firstly, I will share with you how we verify the performance of our system, and then I will make conclusion. First of all, Korea Autonomous Surface Ship Project. The Korea Autonomous Surface Ship Project began in 2020, and the project was funded by the Ministry of Oceans and Fisheries, Ministry of Trade, Industry, and Energy. The project has 4 themes. First of all, we developed intelligent navigation system. Secondly, machinery automation system. Thirdly, technologies for test bed and validation. Fourthly, operational technology and standardization. In this project, we are aiming to achieve IMO level 3, but IMO level 3 includes remote control. Actually, IMO level focuses on remote control and the crew or mariners on board the ship. And we need to classify the IMO level into more details. So just relying on IMO level to talk about intelligent and autonomous navigation is not sufficient for now. So we created a consortium of many parties, as you see here, for the COS project. And we classify the technology projects into 13 different solutions and systems. Some projects begin from 2020 by 2025, and some other projects have different timeline. Today, I'm going to talk about the development of intelligent navigation system and verification and validation of the system. Here on the slide, you can have a look at our plan. We established a maritime test bed in Ulsan. On the slide it says September, but actually in October this year, we will open the Performance Demonstration Center that has various facilities to conduct testings. And our system will be installed on the actual ship in 2024 and go through the actual demonstration. Our system overview is on the slide. First of all, there is onboard system and shore system. In the case of shipboard systems, there is digital bridge that collects all the data from the ships and enables communication between ship and other objects. It serves as a data gateway. There is situation awareness system, autonomous engine system, and incident response system, and so on. And digital bridge communicates with the shore bridge, and the data received to the shore systems can be used for checking the situation of the vessels. The data includes VTS data and other data. Remote control is also available. While conducting the test, all the data is being collected and accumulated in the form of big data. Secondly, I will talk about the development of advanced intelligent navigation system. This is the configuration. Safe and economic navigation are the two important pillars. For safer navigation, we have to comply with the COLAC rules. Based on COLAC rules, the system can create safer routes. And if the other vessel does not comply with the rule, we have to be able to respond to the situation. So the relevant algorithm is currently being developed. Economic navigation is about creating economic route. And there is route decision maker. Once the safe route and economic route are created, then route decision maker creates the most optimal route. The relevant algorithm is working, and the relevant data is also shared with the bridge system on shore. In order to create the safe and economic routes, it is important to understand the operational characteristics or navigation characteristics of the vessel. And our system needs to go through verification through model test, simulation, and sea trial. For this, we have created the verification environment and test environment. This is our model test to identify the dynamic characteristics or performance of the ship. We conducted the test at normal speed and at low speed. And we are also conducting the same test for the real physical ship. This is intent inference-based safe route planner. In the case of fully autonomous surface ships, they should of course comply with the COLAC rules, but there could be other vessels on the ocean that do not comply with the COLAC rule. So if the obstacle ship makes a certain decision not to comply with the COLAC rule, then the own ship should be able to respond to the situation and create the relevant proper route. We have the algorithm that makes this possible. This is the case where the COLAC rules are complied with. But in this case, we have an algorithm to handle exceptional cases. So this is the case when both ships comply with COLAC rules. Based on the collision risk index, the ship can respond to the situation. Next is economic navigation. Weather data is updated by every 6 hours, for example. Such global weather data is used for planning economic route. And under safer situation, they can create a new route considering the economics and the safety of navigation. This is about the decision maker, route decision maker. This is a practical function. For example, when the system creates or plans a route, it should make a decision over whether the created route is the mandatory waypoint or not. If the newly created route deviates from mandatory waypoint, then the route decision maker makes the right decision to recreate or replan the proper route. Then I will talk about how we are going to verify the performance of the intelligent navigation. In the case of autonomous navigation, commercialization and installation of the system requires reliability and credibility. So, in the development phase and in the installation phase and after the installation phase, we should ensure reliability and credibility in the system. So we install the system on the actual ship and apply various scenarios to verify whether the system performs well. As long as we have the necessary resources, we could apply almost infinite set of scenarios and data to conduct the test. Here you see the video image that shows how the system performance was simulated. And in the development phase, we verify the system through model test. This is the model test environment. We created fully automated model ships. The model ships have LiDAR and camera, and therefore we can monitor the actual situation of the model ships. The monitoring was done remotely in our research center. On the top of the slide, you see the model ships used for our test, and on the right side and on the bottom you see the system that was used for situation monitoring. After model ship testing, we need to install the system onto the actual physical ship and conduct another test. The picture here is the shore center. This is the autonomous surface ship performance demonstration center. It includes monitoring system, which consists of digital twin, bridge, and engine. VTS function is also included in the test center, and remote control as well. In the algorithm development phase, we verified the performance of model ships. Now, we should conduct simulation tests for actual real ship. That's why we are supposed to establish a simulation testbed for autonomous ship. This is digital twin bridge engine monitoring system. At CRISO, we have established a prototype mirror system. On the photo here, you see the monitoring mirror system. And as we conduct the real sea trial test, data will be created. Such data can be monitored in this mirror system. We can also check the status of model ship testing from this monitoring mirror system at CRISO.
예, 다음은 이제 저희가 어떤 알고리즘에 대해서 테스트를 하는
Next, our
말씀드리겠습니다.
test of algorithms.
초창기에 작년이었죠.
Maybe last year,
저희 해양공학수조에서 간단한 테스트들을 좀
we conducted simple tests in our marine engineering indoor basin.
시선을 이제 물리적으로 집어넣었고요.
We
화면에는
put
보이지만
the traffic
상해 선박이 하나 더
ship, one physical traffic ship, and although you don't see it in the picture, there's an imaginary traffic ship.
항상 뭐 환경이 좋을 때만 움직이는 것은 아닐 수 있기 때문에
And
저희가 팔을 만들어서
depending on the environment, the algorithm performance could become different. So we created the virtual imaginary wave.
타선이 되겠고 타선이 가상의
This is own ship, and we have imaginary traffic ship here.
보시는 것은 이제 시뮬레이션을 통한
This is our simulation test.
어떤 알고리즘의 파라미터들을 좀 초기 값을
First of all, we set the initial values of algorithm parameters, and we
시뮬레이션을 통해
created various test scenarios.
그래서 몇 가지 이제 시나리오들을 좀 생각을 해봤는데
We
저희가
thought about various scenarios for the test. In the case of our scenarios, they are based on Monte Carlo-like scenarios. When own ship navigates around a certain loop, many traffic ships move around each corner,
로우 상황을 만들
and we create various encounter situations between the own ship and traffic ships.
보여드린 동영상은 저희가 시험한 시험장 환경에다가 약간의
This video shows our test environment.
4개의 웨이포인트를
There are 4 waypoints. Own ship circulates around the waypoints. In this process, traffic ships navigate around the route as well. And then they are supposed to encounter with each other in different ways and in different situations. We tested this situation to see if the algorithm works properly under various scenarios and situations, encounter situations.
네, 다음은 조금 전에 보여드린 그 일러스트레이션에서 실제로
Next
시험을 수행하는
is our actual test.
오른쪽 위쪽에 보시는 것은 저희
On the top right, you see the photo of DTB monitoring system at CRISO. At this center, we monitor the test situation. Below, there are video images we took through drone.
뒤쪽에 보시는 이 내용이 실질적으로
This one,
안에 있는 가상 선박과
it shows physical ships and imaginary virtual traffic ships moving around the waypoint, and it shows how the own ship avoids collision with the virtual ships. And all these ships are navigating with a fully autonomous navigation function. Usually, the test takes about 1.5 hours, and they experience 1,000 times of different encountering situations. And we were able to see that the algorithm worked properly under various different encounter situations.
시험상 아까 말씀드렸던 울산 쪽에 이제 저희가
In Ulsan,
관광 선박과
we
시스템들을 테스트하기 위한 시험선을
established the testbed ships.
저희가 저희 시스템을 탑재할 계획입니다.
We are planning to install our system on the testbed ship by late 2022 or early next year. So maybe next year we will be able to conduct the real sea trial test with the testbed ship.
확보한 실증선 쪽에도 탑재를 해서
And
선의 실제 운항 코스에 대해서
we will install our ship on the actual commercial ship as well, as we signed an agreement with the relevant party.
지금 자율화선박 기술
So we're going to test our system on the real commercial ship as well in the future.
기술 개발이 진행.
As mentioned before, Korea Autonomous Surface Ship project is underway on 4 categories of technology systems. In the case of advanced and intelligent navigation system, it is important to secure reliability of the system performance in various situations and scenarios. There are many researches and presentations about autonomous surface ships and autonomous navigation. Many of them say that we verified our performance by conducting just one-off test, but that one-off test is not good enough. When we talk about the autonomous navigation, the number of seafarers on board the ship will decrease, and the seafarers will be doing other jobs if autonomous surface ships are truly realized. And if we install different systems on the ships, we will still need seafarers and crew on board the ship. In order to realize fully autonomous surface ship operation, we need to go through much more technology development and a much larger number of tests and verification trials. One-off test is not good enough. So, in our case, in the development phase, in the commercialization phase, in each of the system development phase, we are conducting tests to verify the performance, and we believe that this will make great contribution to the development of autonomous surface ships in the future.
It is time to Q&A session. I would like to invite Chairperson Mr. Jin Kim, Project Head for CRISO, and also Mr. Do Hyung Im, Mr. Oscar Levander, Mr. Dong Jin Yo. Please come on to the stage. Please welcome them with a warm round of applause. Also, we will provide an opportunity to field questions from participants for the panel discussion. Please feel free to raise your hand. A microphone will be provided.
네, 제가 받으면 되나요?
So can I start now? Good morning, everyone. As you introduced, I'm Kim Jin. I'm the head of a project at CRISO for autonomous vessel projects. Okay, let me take off my mask first. So in this session, we are discussing autonomous vessels. We have leading Korean shipping companies and the leading shipping companies at Euro Kongsberg with us today. And we also had a chance to hear about projects, autonomous projects in Korea. And IMO has defined the autonomy level, and I wish we had a time to discuss that as well. If we assume that the autonomy level 4 has been defined, and if we target level 3 for commercialization, and we have a products available in the market, if we want to have the autonomy level 3, what should we do? What are the biggest obstacles and challenges to commercialize level 3 autonomy products in the market? IMO level 3 and level 4 include targets of unmanned vessels. Yes, we have technical problems and regulatory problems for now, not only in Korea. I think Korean companies are paying attention to regulations, and Norway and Japan are very active in developing autonomous technologies. So without international cooperation, commercialization of autonomous products will not be commercialized. So we need more efforts from the private sector, the corporate sector, but we have to think realistically. What are the biggest challenges and obstacles facing you to commercialize autonomous products in the market? And Mr. Oscar Lavender, can you hear us? Are you joining us?
Yes. Yeah, I can hear you.
먼저 그러면 여기 아비커스 김재욱 교수님께서 현실적으로 어려운 문제 먼저 말씀해 주시고 그다음에
Then Mr. Im Dae-young, could you first answer the question, and then we will move on to Mr. Oscar Lavender.
말씀드린 대로 저희는
As you explained,
그룹사의 적극적인
we are receiving strong support from our
기사제 업체의 도움을
Hyundai Heavy Industry in terms of materials and our works with Korea Register, our cooperation with flag states. In all these activities, we're receiving strong support from Hyundai Heavy Industry. We are not yet we have not yet achieved level autonomy degree 3, but the ADAS system is very much helpful for you when you drive the highway, for example. You have the experience in the automobile industry. First of all, our system will be installed on the ships built by Hyundai Heavy Industry. And ship owners will, and some ship owners already used our system and they are satisfied with our system. So I don't see much difficulties in commercializing our system. And however, in the case of the solution that has control function, the story is a bit different because we are worried about the reliability of the performance of the system. And Korean big three shipbuilding companies have developed various systems with control functions for over 10 years, but we have not yet made much progress in terms of the control features and collision avoidance system because the relevant regulations and standards have not yet been clearly defined, and there is no clear standards for testing the performance, for verifying the performance of the autonomous navigation assistance system. And soon we're going to receive ABS certification, but there's no international standards clearly defined. So we will have to receive certification again from other class society and registers. So we are worried about the current situation where there is no clear regulation or technology standards. We conducted the field test. We had transoceanic voyage, and I couldn't sleep at all during the test period, during the transoceanic voyage period. I was worried about what if the signal disconnects and what if any problem takes place during the transoceanic voyage test. And I think we need clearly defined procedures and standards for testing the performance and verifying the performance of the systems. Yes, many companies will be experiencing such difficulties.
And Kongsberg has been doing so many projects, including Yara, Brooklyn, and Norway is a coastal country, and it has many complexities at its coastline. In Yara, Brooklyn is an unmanned vehicle, so it's autonomy level 3 or 4, according to the IMO regulations of autonomy. So, Mr. Lavender, what are the biggest challenges and obstacles facing you? And I also wonder the regulations in Norway. Is it possible for an unmanned vehicle to be operated along the coastline of Norway?
Yes, thank you. And well, you can say that to address some of these questions here, the biggest challenge that I actually see for making an unmanned vessel is the reliability of all the systems on board. Current ship systems are not really designed for being without human service, maintenance, and supervision on board a vessel. So there's a massive amount of different systems that needs to be redesigned, and we need to apply a different level of reliability to it, either through redundancy or duplicating system, or then just improving the components and system engineering in it. So that is actually probably the biggest challenge, as I see, to make really big ocean-going unmanned vessels. To overcome this, basically we start with smaller ships that are more local. It's easier to do it that way. And that's why we have projects like Yara Birkeland and Asko and other ships. The other, shall we say, big challenge is the unknown. When we're going to go out there with unmanned vessels, there will be unknown situations that are hard to foresee. And basically solve that topic, our approach is to always talk about remote and autonomous. We have the human in the loop, because we do think that it will take a very long time to go through all the possible scenario that an unmanned ship that can encounter, and a human is better at resolving these unknown situations than an autonomous system. And we need to compare a little bit how much money, for example, the automobile industry is able to put into developing autonomous systems. And that's a system that needs to resolve all issues. And they are still not there. And in the marine industry, we don't have the same amount of billions of funding. So we need to have a little bit different approach. And I think our approach there with having combining autonomous operation for most of the time with a human in the loop for these kind of hard to predict situation is probably the right approach. If you look at a little bit talking about what we are doing and solving this, we are working with, of course, the class societies, and I think that work is doing quite good. The other challenge, as was mentioned here earlier, is then with the regulatory side from the flag state. And in Norway, we are working with the Norwegian Maritime Administration, and that is good. The only problem is that when we go to another country, then we need to work with another flag state, and they might have different requirements, different setups. So we need standardization, and that's why it would be very important that IMO would develop the rules and guidelines as soon as possible. That would help this work. But of course, there's so many things that needs to be addressed that it will take a little bit of time.
Norway, if I understand correctly, is focusing on the coastal areas of Norway. So Norway had some regulations that can cover the coastal operation.
Dr. Yo Dong-jin, as for level 3 and 4, what kinds of technological challenges do you see? There are legal issues already mentioned by another speaker. So what about technological challenges? As I mentioned during my presentation, the most important thing is reliability. In order to ensure reliability and verify the reliability of the technology, this is very important. In order to secure technology reliability, we are trying to demonstrate we have reliability in the technology through certification process and by working on the reliability evaluation process. The technology of autonomous surface ship has already been developed from some time ago in Korea, but I believe that we are a bit latecomer in terms of the technology for autonomous surface ship. So we need to consider what will happen in the future, and we need to prepare ourselves to respond to any future changes in our technology development process. And rather than the technology development itself, how are we going to show that the technology has reliability? This is the very important issue. Then it naturally
드리겠습니다. 우선
links to
가지 좀 먼저
another theme.
스피커들하고 얘기 좀 나누고 나중에
We're going to take question from the floor later on.
현재 하는 배는
Now,
회사 대학이라든가
maritime universities and other educational institutions are producing captains and marine technicians, and we believe that they were well educated and we have them on board the ship. And there are many digital and intelligent systems being installed on the vessels. If we install those digital intelligent systems on the ship, then there could be someday AI captain or AI marine technician. How can you trust the AI captain or AI crew on the ship? In the future, when there are vessels with IMO autonomy degree 3 and 4, then the ship must receive a certification. And how are we going to certify those vessels and systems based on what standards? In my opinion,
현재 클래스들의 수준은
the level of classes across the world is about certifying whether a certain digital system can be installed on the ship or not. In order to install intelligent system on the vessel,
AI 캡틴을 믿고
we should be able to trust the AI captain, and human crew may get some sleep, and if the human crew has sufficient trust in the AI captain, and how much trust can we give to the AI captain? I want to ask your opinion about this issue. We will listen to the speaker's opinion first. Mr. Lim?
인공지능
Mr. Do-hyung Lim? When we have AI captain on board in the future, how do you think we can have trust in the AI captain? Do we have to wait until the global discussion takes place? I think that
말씀드렸지만 자율주행 자동차도 20년간 했는데 아직도 3년
autonomous vehicles, autonomous driving vehicles were research and development for over 20 years, but they have not achieved a full autonomous level. And still, in the automobile industry, there is no clear responsibility defined regarding the AI driver. AI captain is a story that will happen in the very far future.
낮은 수준의 어떤 보조를 하다가 조금
And currently, low-level navigation assistance will be provided by the digital system. And when this system becomes smarter, and the system could play the role of the
그 과정은
captain in the future, but that will not happen overnight. We will have to collect a lot of big data, and we will have to train the artificial intelligence model a lot. And we will have to improve the AI algorithm. And the most important thing is the track records and data.
점점 똑똑해지고
Based on the data, the AI system will become smarter. And if we really achieve level 3 autonomy, then we may not need the involvement of human, but it will take us such a long time. Before that time, data is the most important thing.
오스카 라벤더님
And Mr. Lavender, I will ask you the same question. Kongsberg is developing AI navigation systems, for example, for Yarra Buckland. So my question is, how reliable do you think the AI captain or AI systems will be? So what autonomy level can we give to AI captains or system in the future?
Yeah. Well, thank you. I think, of course, it will take time to develop these solutions and build up the reliability and collect the data and all this. And that's why, as I see it, the development of this this autonomous system will take two paths. One will be that the systems will be applied on ships with crew, where you gradually increase the task that the system will do, and it will work alongside the human seafarers. And that's one path to incrementally increase the kind of autonomy level of the vessel and the responsibility of the system. The other path is to start with smaller and shall we say, a little bit easier applications that operate locally in a more defined area, and develop the solution that works there, and then expand to longer routes and more bigger vessels, and then go to basically ocean-going big ships. If we start with smaller ships that operate locally, we can go unmanned much sooner, and because it's easier to test and verify the system that way. And I think we are working according to both these paths of the solutions. Basically, as in our roadmap, we will go to unmanned ships. That is coming, and we will also see that we will develop the system for having bridge zero. So basically, having ships that where we have crew on board, but where we, for example, nighttime, can run the ship without crew on the bridge. Of course, this will be done in situation where we foresee that is possible. You will not do port entry and exit during night without crew on board on these ships. You will start with having it operate in the middle of the open ocean. Again, where it's easier to let it do. And then I do fully believe that a situation awareness system and an autonomous navigation system is more alert than many ships out there today on dangers and something. So if it detects something, you also have the possibility to call in the remote supervision that can step in and take over the control of the vessel if it was a situation that the autonomous system cannot handle. So you gradually need to increase the responsibility of the autonomous system as testing and verification progresses. But that's why I think it's important that you build both incrementally on existing vessel solutions, and you also go with this thing, we start with smaller, locally operated applications that are fully unmanned, and then scale to bigger and bigger and more demanding and longer routes. That is the pathway to take us to the ultimate goal.
오케이. 말씀은 많이 주셨는데 사실 뭐 제가 보면
Thank you very much for your comments. And I really wanted to get the clear answer to this question. And there is an artificial intelligence navigator being planned, and you showed us a scenario to test the AI captain. And I'm not sure if the current scenario we have is sufficient to evaluate the performance of AI captain. Again, we are thinking about certification process. First of all, we have to clearly define the autonomy level. IMO has 4 degrees of autonomy, but we have to divide the IMO autonomy degree into more details. And as Mr. Im Do-hyung mentioned, Mr. Im Do-hyung showed us a more detailed classification of autonomy degree, more details than the IMO grade. So we need to specifically classify the grade into more details. And as the speaker from Kongsberg mentioned, the equipment and materials on the board are not considering the unmanned navigation for now. And intelligent navigation system with AI will be existing in the future, then what do we have to do? Systems on board the ships should be able to respond to emergency situation, and if there's any problem with the AI algorithm, they should be able to respond to the situation and verify proper performance of this. So we need to define the autonomy level in more details. And as Mr. Lim Do-hyung mentioned, now we have navigation assistance system. And we should start from navigation assistance system in order to ensure reliability of the systems that we're going to install in the ships in the future. And we take different approach from automobile industry. For example, Tesla just put the autonomous vehicles on the road and just collect data. In this way, Tesla accumulated credibility, but that does not work in ships. If there's any accident, the ship accidents will be a much larger scale accidents, which would be very serious. So we should first conduct model ship test or simulation test, and then real sea trials in order to verify the performance of the autonomous system.
저희가 스피커분들을 모시고 이 자율
So we have discussed what kinds of challenges we have before achieving full commercialization of autonomous vessels with the speakers. Now, I'm going to take questions from the floor. Would you please say your name and organization and then ask the question? I am the vice chairman of CAS project, Korea Autonomous Surface Ship Project. Actually, your presentations were very interesting. We are all working in the same industry. Before we achieve full autonomous navigation, we have to use all the existing systems on the ships. The collision avoidance and collision avoidance control are rather simple. But there are existing navigation communication equipment like ACTIS, autopilot, and BMS. We cannot ignore the existing systems like ACTIS and BMS because they are legally approved equipment approved by flag states. And Mr. Im Do-hyung is saying that he's going to supply the autonomous navigation assistance system on the ships produced by Hyundai Heavy Industry, and you must first receive approval from the flag states. Autopilot, ACTIS, all these existing systems are already being used by ships, and if you want to add autonomous navigation assistance system to the existing ones, you have to receive approval from flag states. Then you may face administrative hurdles. You can overcome technology hurdles through efforts, but how are you going to overcome the administrative hurdles that you have to receive approval from the flag states? And how are you planning to overcome the administrative obstacles? Because that's the issue we also have to solve. So this question goes to Mr. Im Do-hyung. Another question goes to Mr. Yeo Dong-jin. In the 18,000 TEU containers vessel, your solution will be installed for real sea trial. And what is your plan for the real sea trial? And how are you going to overcome the same administrative hurdles? Very detailed question. Then, actually, I should have talked about this issue with you beforehand. We are working with Korea Register We are also cooperating with Liberia flag states. We signed MOU with Liberia flag state for approval of our system. Of course, we were worried about administrative obstacles, but this is not impossible.
항해사가 개입을 할 수 있는 시스템이기
The navigation assistance system requires the involvement of human crew, and we are not going to touch on the existing legally approved equipments like ACDIS. And using our autonomous navigation assistance system is rather simple, and we think this is not impossible. And we had very good discussion with Korea Register and flag states, and we also discussed this idea with the Hyundai shipyard. We have also speaker from Kongsberg here. The situation will be similar for them as well. We finished all the necessary discussions and we conducted the test of the performance. Of course, we have more obstacles to overcome. We have many things to do before receiving the approval from flag states. We actually wish we were able to receive approval from flag states, and I think this is possible. Mr. Yeo Dong-jin, in terms of technology, it is possible to use autonomous navigation system along with other existing systems on board the ship. The issue is administrative obstacle. Considering the current situation, we should prepare ourselves for the future. For example, we can respond to the future situations when we have to receive the approval from the flag states. In terms of technology, I don't see big problems.
Since we are behind the schedule, I'd like to thank the speakers, CEO Im Do-young, Vice President Oscar Lavender, and Yeo Dong-jin. Thank you so much for presenting your idea today. And this will end the Q&A session. Thank you.
Vice Chairperson Chin Kim, Project Head for Carrizo, Do-hyung Im, CEO for Abacus, Oscar Lavender, Senior Vice President, Kongsberg Maritime, Dong-jin Yeo, Senior Director from Carrizo. 네, 잠시 매우 중요한 안내 말씀드리도록 하겠습니다. 코마린 컨퍼런스는 해를 거듭할수록 점점 더 풍성해지고 있는데요. 오늘 귀한 시간 내어주신 우리 모든 내빈들을 위해서 식사가 준비되어 있습니다.
I'd like to thank all the participants for being with us, and we are providing lunch today, so you can go down to 21st floor. You will be served lunch, and you will also have a chance to network with each other. So we'll give you enough time for lunch break. After lunch break, we will resume the next session at 1. At 1, we will resume the session. Session 4 will start at 1 o'clock. On the 21st floor, we will serve lunch for you, and enjoy your lunch and enjoy your time to network. So please come back by 1 o'clock here. Thank you.
This is for English person. We have lunch for the participants on 21st floor on this building. And then please enjoy freely and enter the conference room before the next speech begins. After lunch, we will have session 4, seminar for future ships and digital ports. Please enjoy your meal and let's meet at 1 o'clock.